Hi, welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble from Chris Gamble's Analog Life. How you doing today, Dave?
Excellent, mate. How you doing?
Pretty good here. Just the usual list of things to talk about, electronics. Can't wait to talk about them.
Yeah, well, we do have a list of stuff, but it's certainly going to be off the cuff because I really have no idea. I haven't looked at half the stuff, so
Well,
there you
okay,
go.
man.
We're just going to get our opinions, and this is what, show number 4, I think.
Yeah, and show number 4.
Oh,
That's
who
crazy.
would have thought?
Yeah.
There you go.
And we got our site up and
yeah,
running?
thanks. Yes, we've got the site up, and thanks to all our regular viewers who have joined our RSS feed and came over to the site, because we won't actually be posting this on our individual sites anymore. Or, well, I certainly won't. So if you do want to hear the show and find out when the new episodes are, you're going to have to, I'm afraid, subscribe to the new RSS feed over at theamphour.com.
And if they don't want to, I mean, they wouldn't have just heard what you just said there anyway, so it doesn't really matter.
No, exactly. So they can bugger off.
All right, yeah, we don't need them.
No, not at all. We're blazing our own thing.
That's right. Yeah,
Even
so
if we
that'll
have
be-
an audience of 2, just us.
Yeah, well.
Let's still do it.
Just talking to ourselves. Yeah.
Exactly.
Yeah.
Well, we pretty much are, because I'm here in Sydney, Australia, in my study, and you're in your basement in Cleveland, Ohio.
That's
And
right.
yeah, we are pretty much just talking to a screen and a VU meter. So
Yeah.
there you go.
Yeah. Well, let's start with some shout-outs. How about that?
Oh, shout-outs. Yes, let's do it. All right.
Yeah,
What
so
have you got?
Well, starting off from last time, we were talking about the IEEE a lot, and Cherish over at cherishthescientist.net, she had a pretty good response to it. She's in academia, and she was a little more on the positive side of things for the IEEE, but pretty good rundown of all the things that she likes about it, and there was a lot of good feedback on that site too. So some of the things we missed might have been like papers, and I don't really read papers myself, but also a lot of the programming in their local area. So that's real good.
Yeah, well, that's the thing. I did read Cherish's site. I hadn't actually been there before, and her critique, I guess you could call it, of our off-the-cuff comments about the IEEE and how, I don't know, I can't even remember what we said exactly in the
Yeah.
like. It probably doesn't have much role for the average practical engineer and stuff like that, and yeah, maybe they need to, I don't know, change or something like that. But yeah, they were just off-the-cuff remarks, And
Well,
of course they're going to have a niche sort of, crowd. But my comments, well, first of all, I'm not from the US, and they're predominantly a US-based
that's true.
organisation.
That's very true.
That's where the majority of their people would be.
Yeah.
And but still, I can talk about it. And let's certainly talk about it. And how, I would love to see their stats, but I would still bet my bottom dollar that that their percentage of people who join, and then let alone people who are actually really like it and are join apart from just having something to show on their resume or something like that. I think it would be quite small. They're actual people who actually take the IEEE seriously.
Like the
as far as
participation.
practical work in engineering,
Yeah.
as far as active participation and all that sort of stuff, I think it would be very low among the the practical working engineers. And I guess that's the angle we were coming from.
Yeah. Well, another thing I think is, Cherish is in academia too, and one thing
Yeah.
that I love when I was in school is you can get, if your school buys it, the IEEE has this ridiculous database of papers, and if you're just on your own, you got to pay like $30,000 to access all that stuff, $10,000, $30,000, something like that.
Yeah.
And so if you can't get at that stuff, that's a big chunk of really useful stuff that, maybe you can't. I'm not buying that for myself. I don't want to read papers that much. But if you're in the academic world and you have access to that, that's a pretty spectacular thing right there. So,
Well,
it could be an academic
Yeah,
versus
well-
outside academic kind of thing.
Well, that's the thing. I mean, they have a big role to play in the academic world, but, that's totally, the academic world is a totally different scene to, real world, Dilbert-style engineering. It's just, it's totally different. So I not bagging the IEEE in any way when it comes to that sort of thing. And just coincidentally, I got the IEEE Spectrum magazine yesterday.
Oh, yeah.
And I'm flicking through, and, it's not a bad read.
Yeah.
But there's one thing I'm going to have a bitch about, okay? And I'll have to put a link
Go for
to
it,
this.
Dave.
And, here we go, right? Page number 2, right? There's an e-reader face-off. The Amazon Kindle and all those, the Sony,
iPad.
And the iPad and all those e-readers. Well, I just bought a Kindle and I'm waiting to get it, and I so wanted to read this article, and they're hyping it up in here. It's not in the actual magazine, but it's actually online, and they said it would be online August 17th, and surely it was. And and I jumped online to read it. They saying, they spent 3 weeks with like 9 or 10 of these different e-readers, and they've got all of the editors of the IEEE Spectrum spent 3 weeks reading them, comparing them, and they're going to do this mammoth review. I couldn't wait to read it. I jump online, and it's the shittiest, crappiest review I've ever read.
And Dave knows his reviews.
Awful.
You know your reviews.
And I know my reviews, yes.
That's right.
I'll have to provide a link to it, but it was so disappointing. It was literally
that's too bad.
24 sentences, and then a one-sentence response from 3 of the people for each of the readers, and that was it. And they spent 3 weeks, and they had half a dozen of their editors playing with these things, and that's all we got.
Yeah.
I'll have to... Anyway, shit.
Well,
so, IEEE Spectrum editors, lift your game there, really. That was very disappointing.
Maybe they got... Well, I was going to say they ran out of room, but then you said it's only online, so that's probably not the case.
It's only available online, yep, and they could have provided, even taken them, I would have been great if they could have taken them apart, but I can understand if they don't do that. But a couple of sentences, that's all we got. Got to be kidding me.
You don't approach Dave Jones with just 2 sentences. Come on now, people.
No, exactly.
maybe
they'll
make it up for
serve,
you.
Yeah. Anyway, I wish they'd send me the e-readers. Jeez,
I know, right?
Tear them all apart, and I'd do a 1 hour shootout. Anyway,
I've seen what you do to DMMs. I don't think
today.
we want people dropping e-readers off of cliffs or anything like that.
No, that'd be fun though. Geez,
it would be.
So,
that's like the
Amazon Kindle and Sony.
Have you ever seen the Will It Blend? Have you ever seen that before?
Will It Blend? I love Will It Blend. Yeah,
this is brilliant. It's like I don't know where they came. I mean, I guess are they selling the blenders? I guess they're selling.
Yeah,
them.
the deal with that is that the guy that owns the company, I forget his name off the top of my head. It's actually a viral marketing campaign. Yeah. Believe it or not,
I believe it.
I thought it was just something that he started up on his own, but no, it's actually
some sick dude.
They actually hired a marketing company, and that's what they came up with. They said, look, get on camera, blend some stuff, and it took off. So and it's massively popular. When he blends like the iPad and the iPhone, and they get 20 million views.
I know. You want to see what it looks like, right? I mean, like that's what everybody wonders about. It's like, I want to see that stuff blow up.
Yeah. And the guy is just, he's just so bland and dry.
He's like
it's
deadpan.
just funny, It's just, deadpan kind of, personality. And I think it really works well. It's brilliant.
Yeah.
And, I was hoping to be able to, send him some meters or something like that so that they can actually blend, a Fluke multimeter or something.
There you go.
Unfortunately, they're very hard to get contact with.
Oh, really?
So,
okay. Yeah,
they're very cagey.
I guess if you're at the top, I mean, like that, it's like 20 million views. That's a lot of views.
So. Oh yeah, and you'd have every Tom, Dick, and Harry, wanting to send you stuff and do a video,
sending
and
you
blend
cats
and things like
and
that, so.
puppies and no.
Yep.
Okay. Don't send PETA after me. I don't do that to animals. I love my 2 dogs.
I loved it. Oh, I'm glad to hear you're a dog man, not a cat man. I despise cats. I'm sorry, but the only good cat is one squished between the tread of my car tires. That's the only good cat. There you go.
Now we are going to get boycotted by PETA or something like that. Animal protective.
Fantastic.
Yeah.
Controversy. Yes, I love it.
People love that. Well, what about other shout-outs? What else do we have on here? We got Let's Talk Geek. Do you ever listen to those guys?
No, I haven't, unfortunately.
Yeah.
But I'll have to give them a look.
Yeah,
Let's talk to Geek. What do they do?
They're kind of more general technology, kind of like somewhere between us and Leo Laporte. You know Leo Laporte's podcast. He's all like, just generic tech, kind of like Apple and stuff like that. But these guys are actually out of South Africa, so I listen to that and I think, man, I got Dave and these four guys, and does anyone talk like I do?
Right.
Yeah.
Oh, yeah, they're the guys that emailed us. Yeah, I think I had a quick look, but I haven't actually heard their podcast. So it's actually a podcast show, is it?
Yeah.
It's a podcast radio show.
Yeah, it's out of South Africa. It's actually pretty interesting though, because one of the guys is doing the thing I wanted to highlight about it is one of the guys is doing a Lego Mindstorm project, and he was talking about, and I'm not sure about the conversion rate, but he said the boards cost $600. Now I know
That's ridiculous.
Yeah, right. So I think it was 4 or 5 boards for $600. I'm not sure if the conversion rate was wrong, and I forget what the South African currency is called, but it's 7 of the South African currency to an American dollar.
Oh, no way.
Yeah, so I'm not sure if that's what the discrepancy was, or if it's actually $600. I mean, you got to feel for that guy, because that's a lot of money to pay for 4 boards. I don't know what you pay for proto boards out there.
Well, Australia's notoriously expensive, but it's nothing like that. We might pay, at worst double for something here, that you can buy in the US. So a Fluke multimeter that's $400 over there is $800 here.
Man.
But
That's crazy.
But I can't imagine 6 or 10 times or something like that. That's just
I know.
Yeah,
I mean, you can get circuit board specials where you get 4 layers and even silk screen for $150 or something like that, and you'll get 5 boards. And I mean, there's some really, really good deals out here. I mean, that doesn't sound if you're just starting out, you're like, holy crap, $150. But if you start doing it, and the 4-layer thing is good too. I mean, it's got silk screen, it's got solder mask, it's got all the solder mask. Sorry,
solder mask.
Solder.
Yes.
Sorry, I'm still
very good, Chris.
I'm going to start talking I'm going to start talking like an Aussie around here, and people are going to look at me funny. Yeah, but so it's reasonable, I guess. I mean, it's always relative. I mean, if you're paying $600 from the beginning, then you're going to be used to it. But
yeah, I guess. But yeah, I mean, you have to be really careful. I mean, I'm getting my boards made in China. All of my personal boards done there, because we can't get them done here really affordably. You can just pay from China, even if the courier costs you $30 or something. It's still cheaper than getting them made here.
Yeah, and you wonder about that, when gas prices petrol prices. Man,
petrol prices. Thank you.
This gap between us, Dave, is just so hard to forge.
I know, it's ridiculous.
Just before the show, Dave was talking about
Here I am wearing a jumper,
yeah,
because it's springtime here, and you have no idea what a jumper is.
I thought he was talking about
somebody jumps off a building in, jumps off the Empire State Building.
That is not what I said. I said
I
thought you were wearing a jumper is what a baby wears around here. So I thought Dave was wearing baby clothing.
There you go. So it's a sweatshirt in the US, right?
That's right. I'm sure it's called something else. Anyways, cultural differences aside, I mean, you wonder about when fuel prices go up, what's that going to be for? So even if it is 50% cheaper in China, it's going to be eventually it's going to come back to you.
Oh yeah, of course.
Yeah. So I wonder about that in the future. Right now, it's a spectacular deal, but as soon as fuel prices go back up, that could start driving businesses back to the local. I think we talked about that in one of the previous shows about.
That changes the whole world economy. When things start getting more expensive, transport starts getting. People take transport for granted.
Oh yeah,
I've mentioned this before, and it's I think people are in for a real shock when they can't get their fake dog poo from China for 2 cents anymore.
Is that a hot item these days?
The fake rubber dog do.
Buy yours today. We'll try and throw a link on the website.
And I remember back in the 1980s, it was Taiwan.
Oh
yeah. Anyway.
Yeah. Well. Yeah, we'll see how that goes.
Have we got any more shout-outs?
I think that was it for that stuff. We're talking about manufacturing. Maybe we could talk about some of the current events in the U.S. I don't know if you read about it at all with the manufacturing bill in the U.S.
No, I haven't read about that. Are they trying to sneak through another bill? Are they, or is this a well-known thing? Or
it was signed in the other day. It's not that well known. I was reading actually some of the legislation, and oh my God, snooze fest. Like
right.
I don't know how they do it, but this one was, if you are trying to make something in the U.S. and you can't get something domestically, so say you get some kind of chemical that is just not made in the U.S., basically this bill was to cut all tariffs and taxes on that stuff so you can import it and make stuff here and then hopefully export it again. And I think it was that kind of thing. And, there's a lot of, like, protectionism going. I don't know how Australia is, but, like, it's kind of like a big fight for, like, protectionism of, like, trade.
Oh, yeah.
Like, trying to not do that to encourage trade between, like, U.S. and Mexico, U.S. Canada, or even U.S. China. But there's a lot of crap that goes into that, and it's hard to really come down on one side of the issue, because one side of it's like, well, if you really jack up the price, like for you, you have to pay double the price, and a lot of that's probably because it's not made in Australia. Whereas if you made it 4 times, that doesn't necessarily mean someone's going to go make a multimeter in Australia because your market's not big enough. So it's like, I don't really know where you come down on that side of things, but it's so it's kind of just something that's happening around here. And you look at the actual stuff that's in the bill, and it's stupid stuff. It's like, well, not stupid. It's stuff that I don't understand. Like polyvinyl chlorofluoro duo. I don't know, but
and the I've heard that basically in the US there's lots of state-based infighting too, isn't there? With some sort of manufacturing. We want to keep jobs in this state and. And governors of certain states, fight over, who's going to get the jobs to build a new nuclear submarine or something like that. And,
it gets even worse than that. I mean, I've seen it at the local level where, we'll have a city center like Cleveland, right? And they'll have, back in the day, they had tons of manufacturing. So city center Cleveland has, 100,000 jobs in electronics. Yeah, right. But still, let's pretend. Yeah. And then you'll see all the suburbs all around. They'll start forming as people move out there. And then these governments sprout up in the suburbs, and then they start giving these ridiculous tax breaks to try and lure people out of the city. And so then they move their headquarters. They're located in the suburbs, and then you move even further out, and all these different little local governments end up fighting with each other because there's no.
Oh no!
Yeah, it's crazy, and I don't know how that's done in Australia. Nuts. But, like, it's similar here. And, well, it's certainly not that bad, I guess. But, local governments can be a real pain sometimes. Oh, yeah. And, I mean, it's more for, like, the companies that are just in offices, because then it's really easy, right? You just have generic offices in every little suburb. And then as you move outward, it's just you get a barren center and you get these really cheap suburb offices outside. And it's, we don't need to talk about government that much, but it just hurts because then there's all this spreading. So I really like when, I'd love to work in a downtown area. I'd love to be able to, like, walk to a sandwich shop, but, we don't have that in the U.S. because there's just so much room. I don't know how Sydney is, but it's...
well, Sydney's pretty crowded.
Yeah.
It's, 4 million odd, 4.5 million people in the Sydney basin.
Yeah.
Which is same as the country of Singapore, really. It's the same, density. So, Australia's getting overcrowded. We're going through a thing. Well, not really Australia's getting overcrowded, but everyone who comes into the country, they either want to live in Sydney or they want to live in Melbourne. And, and it's unsustainable. So, anyway, I won't get into that. It's one of my pet topics, overpopulation and things like that. So, but that's the problem. I mean, in the 1940s, we actually had some sort of law in Australia, whereas if you came to Australia as an immigrant and you wanted to move here permanently, well, we told you where you had to go and live for a certain amount of time. And, so that,
It's like settlements.
So... I think it's a great idea so that all people don't congregate in the major cities and, overcrowd those cities while the other smaller town centres go to waste, because they're dying because everyone's moving out. So,
well, it's kind of like what we've talked about with the, in a previous episode, we talked about critical mass of, I forget what you were referring to, but, I think it was like online communities. That's a really big deal to have that in a online community at least. And it's almost the same thing in like a technology situation where you want to have as many like technology work. You want people to, like, if they're like technology workers, you want to try and draw as many people in as you can. So you get this really good soup of like, hardware engineers, software engineers, and like they all want to start their own companies or something like that. And you want all that stuff to kind of just mush together. And so that kind of contrasts with like the overpopulation thing. It's like you almost need the like you think about like a San Francisco, right? You got so many like nerds jammed into there that you're just bound to have a couple companies come, and not just San Francisco, but like the Silicon Valley. There's just such a critical mass of people there, and even more so, years back when Silicon Valley was really pumping, that like that's a big deal. So it's like, how do you really balance those two?
Well, it's one of those, one of those very fine line things, and you have to keep an eye on it. But unfortunately, governments and countries are all based on actual growth, and to get growth, they think they have to do that through greater population. So there's a big debate going on in Australia at the moment, and about should we? Because we're growing at the greatest rate of any country in the world at the moment. I think we're like the top 1 or 2. And Australia is, and it's not because it's not because of there's more people being born here. There's not. We're just people are moving here, and we're just accepting so many people, and
Wow.
Anyway, let's.
Well, after this show, I will be able to move there just because I'll know all your little idioms and. I'll have to practice.
Right, you'll be able to talk like a local. There you go. Solder.
Solder.
G'day, mate.
Right, yeah, but what you said.
There you go. Good on you, Cobber. Yeah. No worries, mate.
All right.
She'll be right.
All right. So let's talk about what we talked about last time too. Some of that HP stuff, real quick. We can just follow up on that.
Oh yes.
So you had posted something about the CEO actually getting $40 million instead of $30 million, which
that's the talk going around. Yeah,
that's
$40 million.
Stupid,
his package may be worth upwards of $40 million.
Good Lord. But I also posted something about how, because of all that, and because the stock price dropped out because of all this crap that happened, now you got all these shareholders who are like, hey, remember us? We gave you all our money. We hate you for doing that. So that's kind of the follow up right now. And
right,
man, I don't know. I don't know if Mark Hurd deserves what he's getting, but I'm not shedding any tears over here.
Right, okay, so it looks like the shareholders may hang him out to dry, huh?
Yeah, who knows? I haven't seen any updates on it.
Well, I hope that happens.
Yeah.
Yeah, because I'm sick of these big, the CEOs and everything getting these golden parachutes. I think it's just ridiculous. But then again, if I was in their position, I'd want the money too. So, it's one of those.
Yeah, you wonder, right? I mean, well, I don't think I'll ever get there, but, maybe someday when the amp hour goes national and people actually care about electronics.
Right, yes, and we're a big conglomerate and...
Yeah.
Yeah.
I don't know about that one.
Excellent. But, just back on the government bill thing, was that a thumbs up or a thumbs down from you on that government bill? Is it a good idea or bad, in summary?
Oh, I don't even really know. I mean, I guess good, because if it can't be made here, you don't need to protect locally. But I mean, that's almost a reason for the people to move production elsewhere. So say you're making you're making Dave's Special Formula A in the U.S., right? And before you got all these tax benefits from it because you didn't have to, your customers didn't have to pay a tariff on it. Well, now you move it over to China, you make Dave's Special Formula A there, and then you ship it back here. And now there's not any penalty. So, I guess it's good, but. In the end, it's really
but there could
nothing.
Be some traps. Yeah,
it's really a nothing. I mean, it's really I wish they could have done more, but I don't really have any solutions for government. So
right, okay, no problem. Have we got any listener suggested topics?
Yeah,
I think we've got a ton of them, don't we?
Oh, here's my favorite. Well, I guess bringing it up even will kind of negate it, but.
I think I know what you're talking about.
One of our readers, Mike, he asked if Dave could go an hour without mentioning the Woz, but
the Woz. There you go.
That'll be
apparently I am besotted with the guy.
Yes. I don't know if you got in touch with. You said you were going to try and get in touch with them for your trip to the U.S., but
No, I haven't
yet.
done that yet.
Nothing
but,
yet.
I think the industry's got to have high-profile people like that. Even if they're not as good as they're made out to be, or they're, I think the world just needs, figureheads like that. Who are just popular because they did something cool once, or did just one thing good once, and they're sort of living off that for the rest of their career.
Yeah.
I think that's great.
Or even
I
if
have no problem with that.
Even if they're just making a radio show with someone from across the world, like sometimes you just have to have really awesome, popular people doing that kind of thing.
Well, exactly, and we have a couple of people like that here in Australia, and it's just they're figureheads, and they're just famous not for being famous like the Hollywood celebrities. They're famous for for doing stuff either in the past, and they just continue to hold they just continue to be well known, and I think that's the same with the Woz.
Oh yeah,
and he's done some really cool stuff, and because he's not into the big business side of things, he's more down to earth, he still wears a calculator watch and, stuff like that. It's just,
well,
it's
Mike,
just really great.
We basically just gave 2 minutes to the Woz, so we'll try again next time.
Go.
Maybe we won't mention it next time, but for now. But, some of those people... Oh, go ahead, yeah.
But yeah, and if you haven't read the Woz's autobiography, I highly recommend it. I Was. It's a really good read. There's electronic. It's really the only biography I've ever read that's basically an electronics hobbyist biography,
oh,
and
wow.
he talks about which I think is why it's really great, because he talks about hobby electronics when he was growing up, how he optimizes. How he optimized designs and build his own computers and stuff like that, and I just think that's really great.
Yeah, that's pretty
It's
cool.
a really good read. So there you go. I Was. Check it out.
I think there's there's a couple things I had on here, and that's kind of that same, I won't say hero culture, but like the real movers and shakers of the make community are kind of coming together like that too, and you'll see people like one of the items I have in here is about how some of those guys are touring the country now even, and it's Jimmy P and oh crap, I can't even forget who it is. I remember who it is now. But, they're actually touring the Midwest and going to all these hacker spaces and really hanging out with a lot of people. It's pretty cool. And, it's Mitch Altman. He's the guy that did the TV Be Gone. He invented that at first.
Yep.
And those eyeglasses that do binaural rhythm kind of stuff in your eyes to help you meditate. So, I mean, there's kind of these people rising up and being leaders in an emerging field even of, like, hobbyists, like straight hobbyist stuff.
Yeah, for sure.
And it's you're like you said, it's a good thing. It's somewhere you look to them as a source for like new links, because people are going to be if you're talking to Mitch Altman and you're maybe working in your garage 24 hours a day on this really cool thing that you haven't been able to tell anyone about, but maybe everybody wants to tell Mitch as he comes through their town, and then he posts it somewhere. Then
he posts it in your exactly. You go great guns, because you've been mentioned on the, in Make, or you've been mentioned on the EEV blog or something like that.
Yeah, exactly. Yeah,
So I can just picture, like, these guys touring the country, turning up to a Make lab, and everyone turning around, look at them as they walk through the doors, just like in the saloon, and they, we are not worthy, we are not worthy, the old...
Style,
yeah.
Well, that same kind of thing's happening too with there's other people like that, like I think his name's Bree Pettis, the guy that does MakerBot.
Yep.
And did you click on that link I sent over to you, the Make Me a Sandwich thing?
Make Me a Sandwich thing? No, I haven't. I'm sorry about that.
Oh, it's brilliant.
Where's that one?
It's
shoot it over.
Okay, it's I can't even find it now. Oh, here it is. It's so Bree Pettis, he have you ever seen the XKCD comic? If anyone hasn't seen XKCD before and you're listening to this,
oh, it's great.
Go there right now, please. Just spend the rest of your day there. But there's that one comic. One of Randall Munroe's most famous comics is actually someone saying, "Make me a sandwich," and then the person says, "Make it yourself," and then he says, "Sudo make me a sandwich," and they said, "Okay." So that's a Linux joke, obviously, and
right.
So
which I don't get because I don't speak Penguin.
That's
there
right.
You go.
So Bree Pettis, though, he made a basically like a bread and cheese dispenser, and and the bread is dispensed kind of like in a vending machine with like those coily things where like it'll come down on the coil and it will spit out the oh crap, trying to send Dave this link right now. It'll spit spit out the bread onto a slab, and then it'll spit out a piece of cheese on the top of the bread, and then it'll shove it into a toaster oven, and it'll do all this stuff and automatically and pop it back out, and you'll have a toasted cheese sandwich or a grilled cheese, whatever.
Oh, fantastic!
And it's great. So and it's all done with a console, so you're actually typing in sudo make me a sandwich now, and
oh right, and it interprets that, and right.
Yeah, it's good fun, good fun.
Yeah, that's pretty cool. Those guys that make are great.
Yeah.
And yes, Bree, he actually is a fan of the EEV blog. He actually watches it. So, hi Bree, how you doing?
Hey, all right. Hopefully he listens to this too. Yeah. So yeah, we love those guys over there. And actually, another thing that Bree mentioned was about Fab Labs. Have you ever been to a Fab Lab before?
No, I haven't. I would love to, though.
Terrific. Yeah, I got a chance to. I volunteered with a STEM school around here. It's really awesome. It was like science, technology, engineering, and math. And so it's these kids just doing projects all day long. And it's called, pitch for them is MC Squared STEM in Cleveland. It's this really great program. I know some of the people running it. And I got to see their Fab Lab. And you go there, and they have an Epilog laser. They have all these like wood cutting machines and stuff like that. They have soldering equipment. They have a reflow oven, and all this stuff. Basically, it's like make incarnate, basically. And
cool.
When I was there trying to help them work on a board cutter that they had just gotten. And while I was there, one of the kids that was there, he pulled up a site online, and he clicked a couple buttons, downloaded a file, put some plastic into the Epilog cutter, and as we were working there, probably like an hour later, he had an entire set of pieces to make a Connect 4 game set.
Oh, very cool.
And it's
that is awesome.
Why didn't I grow up 20 years later? Like, that's so cool.
I know. Make your own toys.
Yeah, I know.
Awesome.
I know, and so you just wonder.
Yeah, I'd love to have one of those 3D printers. That'd be great.
So cool. And it's like you wonder though, if the technology keeps progressing, is eventually maybe the Walmarts of the world aren't necessary anymore. Maybe you don't have to ship tiny little pieces of plastic from China over here. You just make it at home.
Yeah. But, please, I don't want Walmart to go down the toilet, because I love getting those emails. Have you seen the emails of the people of Walmart?
No.
It's called.
Oh, yeah.
All these, quite ridiculously looking and dressed people at Walmart.
Oh, yeah.
I get these email updates regularly.
Those are fun.
Just hilarious. I'm sorry, I had to mention that. You mentioned Walmart.
Yeah.
It's just a stereotypical American...
Oh, yeah.
Sort of thing. It's very humorous to us Australians. I'm sorry.
Well, it's humorous to us too.
Right. Okay.
It's more of a human race kind of thing, It's It's wow people. But yeah, I mean, maybe someday, it's kind of like going back to that local economy kind of thing too, where if you have all these tools and gas prices or fuel prices are through the roof, maybe it eventually becomes a reality where you're making everything for yourself. Maybe you're making. I've seen articles before where people make replacement parts for their dishwasher. I think that was on Make too.
Oh yeah, yep.
And it's like that's totally conceivable.
Absolutely.
The only thing that's really not conceivable is maybe a manufacturer giving you the IP to go and actually make that part, because that's how they make their money. But,
well, exactly, and it's only simple stuff you can make. I mean, of course, nobody's going to be able to make an IC at home or something like that.
I don't know.
It's crazy. It's just not going to happen.
I thought your friend Jerry does that.
Oh yeah, and it's got one transistor. It's like it's hardly There's a reason why it costs $5 billion to make a fab plant to make your little 20-cent
right.
Chip, so there's there are limits to that. So, but no, certainly, some things that can be made with these 3D printers and things like that, by all means, yeah. It could certainly, change the fabric of the manufacturing industry. If these things, you'll be able to buy them on eBay soon for $100.
Yeah,
I guarantee, in a couple of years' time, you'll be able to buy a 3D printer.
Yeah.
I'm sure. for 100. But you won't have to make it from the MakerBot kit, or I'm not sure how good the MakerBot kit actually is that does that. But yeah, there's really not much. There's not a huge amount that goes into them. So I'm sure, once China gets,
I think there is a lot that goes into them, but it's more widespread now because of the open source of the MakerBot, and there's other projects out there too. I think that's what really has developed this stuff, opening it up, because before you couldn't get one for less than 20 grand, and now
I know it's
pushing down. Like even the professional ones are down in the $1 grand kind of price range.
Yeah, exactly. Yeah, I would love to get one for work. I'm trying to convince people. Oh yeah, we really need a 3D printer.
Yeah,
that'd be great.
Yeah, that'll be like 3 different like busts of your head sitting at your house. It's like, where'd you get those, Dave? Oh, we got a printer.
Exactly.
But I look good, right? I mean, like,
yeah.
Yeah,
but yeah, they will really, you can bet your bottom dollar in a couple of years you'll be able to get one on eBay for $100, I'm sure. And when that day comes, it's going to be awesome.
Yeah, definitely. And I mean, like it's great for like the rapid prototyping kind of stuff. That stuff is like we've talked about that before too, about just like the greater expectations and turnaround times. It's almost a curse. It looks like a blessing up front, but it's actually a curse because now there's added requirements. I mean, like you as an electrical engineer now might even be expected to go use a Google SketchUp or something like that and actually just go make everything.
Well, exactly. I mean, now all of the EDA CAD packages are all supporting, 3D, 3D mechanical stuff. That's the big move, in the whole industry. So yeah, the individual designer is expected to be able to be, to at least be able to do basic level mechanical stuff and integrate it with the PCB, and you do your 3D model before you even make it. Does your board fit in? And and it really is. It isn't really a gimmick. It really does work. And, yeah. And it's worth putting that extra effort in so that up front you can see that your project, how it's going to look on, you can see it on screen exactly as you make it. And it's just, it's brilliant.
That's
absolutely
cool.
Brilliant.
Yeah, I've never done anything like that. But actually, I was talking to Design Spark on Twitter today, and they had asked, I think they're talking about trying to put their free online CAD program, like pairing it up with Google SketchUp.
Right. Okay.
Which would be cool. I mean, I like that idea. I mean, both are free, and
absolutely.
I
haven't really used Google SketchUp. I've heard of it. I think
easy.
I had a little play with it once. Is it really easy to use?
Oh yeah,
some idiot like me can, because I'm hopeless at CAD packages. Using AutoCAD and stuff like that. I just suck at it. But I can. I've manufactured a few little 3D models of my watch. My actual calculator watch case, and I managed to do that. So it isn't that hard in the end if you sit down and and actually try and do it.
Yeah, SketchUp's pretty easy. I mean, it's a lot more intuitive than a lot of CAD packages. I mean, I don't want to speak against other CAD packages because I haven't used them, and Google SketchUp has its own limitations. But I mean, I've made a model of my house. I've made a model of a lot of different things.
Awesome.
So, I mean, and it didn't take long either. I mean, it took a while, but it probably would have taken about 3 times as long for me to learn other packages before I would have been able to do it. So, it's interesting. We're talking about people having to do more work per engineer, even just per hobbyist. Like being expected more of each individual. And one of our listeners, John S., he had asked about microcontrollers and how people that grow up learning microcontrollers, then should they even bother learning discrete components and stuff like that? And I mean, but I think it's a valid question because everything kind of gets abstracted to a higher level. Microcontrollers can blink a light on and off, right? You can do that with an oscillator that you design with bipolar transistors.
Sure, yeah.
But it keeps getting abstracted to a higher level with either code or software packages and stuff like that. So I don't know. What do you think? Do you think people should still learn all the basics or have them around, or just kind of know it at the top level and then kind of scrape the rest?
There's no doubt. I mean, the answer's obvious. You have to know the basic building blocks. There's no way to avoid them. Sure, you can flash a LED with a LED, but with a little 5-pin PIC micro or something like that. But it's, that's just not good enough. How do you, sure, they've got ADCs built in, but, you need an amplifier on the front end often to do that. You've just got to know your basic building blocks. That will never, ever change. Anyone who says that, you shouldn't learn discrete design or you shouldn't learn discrete gate design and stuff like that is just, is just really has no idea, I think. So, yeah, I think the answer is yes. You must still stick with it.
I mean, I think about it too. I mean, I think about the availability of information these days, and even the specialization. I mean, there is a lot of generalists out there where, I talk about analog a lot, but I'm still using micros and stuff like that. And I think a lot of people have that broader experience, but some of the nichier. I don't know if I would call components nichier stuff. I guess, but I mean, I agree with you that people should learn it, but I'm not sure that people need to specialize because it just keeps getting abstracted. I mean, you think about like a part that LT makes. They're making parts that like you almost can't make on a full circuit board. They're making it on an IC. Yeah, exactly. So some of that stuff gets so abstracted out where you're just throwing a SPI signal at it or a I2C signal, and it's just doing everything for you.
Oh, absolutely. I mean, there's no doubt all these application-specific ICs out there, they're just, as we've mentioned these before, I'm sure, they're absolutely phenomenal, but, you're always going to need, a power supply, you're always going to need filter caps, you're always going to need amplifiers, it's just, the basic building blocks are the foundation of the whole industry, So to only learn micros and think that you can get away with actually designing something is pretty naive, I think. So, I mean, there are going to be examples where, yes, you're only going to need, a 5 volt, a 5 volt power supply or a 3.3 volt power supply and a whole bunch of application specific chips, but that's pretty rare, really. I mean, you're still going to need to know all the basics. Yeah. So
it's kind of
no
interesting
escaping it.
As you kind of work your way down the hierarchy of stuff. You think about people that are like a Java programmer. They are so in the clouds of like you don't ever see. You're not seeing a little bit flip. You're not writing Java in order to flip an LED. Exactly. But you kind of have to work your way down. So maybe you're a Java programmer and you go out and you buy a Beagle board or an Arduino and then you learn that stuff. And then maybe the next logical progression is, hey, well, I want to actually like be able to use a DAC and then amplify that signal to make a speaker, and put it through a speaker so I can, make some kind of digital music. And then you kind of keep working your way down to the bottom. So maybe it's more of a, yes, you need to learn it, but no, you don't need to learn it at first. You'll get there, like. Oh
no, don't, by all means. I'm a big fan of just learning whatever you want first. You don't have to learn. Like, I hate some university courses, and they teach you, they spend the first year and they teach you the physics of how electron flow, and like, what's the point? Right. That is ridiculous. It's boring, and it really isn't very useful to your average practical engineer. In fact, it's totally useless almost. So by all means, if you want to learn microcontrollers first, do it. And there's nothing wrong with that. It's just, just realize eventually you're going to have to learn your basic building blocks, and then ultimately you might find for some niche application, yes, you have to go back right to the physics of it and stuff like that. But to start from the bottom end and learn Maxwell's equations and work your way up is just
it's almost harder to go horrid. From the bottom up like that, where you're starting with the basic, like how do you get from quantum physics? I mean, not like people start at quantum physics, but how do you get from that up to billions and billions of electrons flowing through a resistor, and then trying to figure out, there's going to be some kind of relationship between voltage and current. And what is that called? Yeah. There's a law for this. Oh, okay.
Yeah, exactly. And everything you've learned up to that point is pointless because, you just work from that basic Ohm's law and so on,
Right.
And electronics is like that, it's the whole gamut from that quantum world right up to the macro level, plugging an entire board to do something, kind of, use a 10 million line operating system to flash a LED.
Yeah.
That's, it's
Windows,
it's
LED.
really amazing. Yeah. Windows LED flasher.
That's right. Only $400.
Yeah. And you need a cooling fan and everything
right,
else,
course,
and a 200-watt power supply to actually flash your LED, And that's, seriously, you can do that if you want. You can boot up you can build up a modern-day computer with an operating system and flash a LED. It's just crazy.
Yeah.
So
such a built-in cost then, It's like it's not really worth it then.
no, it's not. But the fact is, you can do it, and you might want to do it for some niche application. Who knows? So,
true.
The whole, that's what I'm saying. The whole gamut, the whole spread of electronics is almost infinite. Of stuff that you can work on, and so there's no hard or fast rules there.
Yeah.
Not by a long shot.
So what happens when say you're using say your little project that you still haven't told us what it is, and we don't need to talk about that now, but say you're using an ASIC or an op amp even, and you think something's wrong. What do you do then? I mean, like, I know when I have that stuff, it's like I usually try and ignore the concept that the chip is wrong until the very end. But have you ever had it where the chip is actually in the wrong? It's like operating out of specification?
Well, that happened to me yesterday.
Wow.
My project failed, and I thought it was all sorts of things because it's been, you get led down the garden path a lot. You think it's one symptom, and and it turns out that it looks like my chip has actually died for some reason, and I'm not sure why. I was measuring. I eventually got it down. It was 2 ohms across the power rail, and that was causing all sorts of things. And I narrowed it. I thought, my cap's failed. My DC to DC converters failed. All sorts of things have failed.
Yeah.
My bypass cap. No, I narrowed it down to the chip. I haven't actually desoldered the actual chip yet, but it's just. The chip's died, and
there's blowing it up. I mean, like, I'm not saying you blew it up, but I mean, there's failure modes. But I'm talking more like, have you ever had it where say an op amp is just like not working right? Everything else is right. You've checked it 100 times, and then maybe the op amp, it's just you got too close to the rail or something like that. Maybe you didn't. I mean, maybe it is specified, but it is not working right. And I was just wondering about that because op amps are maybe a simple example, but you think about like a DC to DC controller, like the thing that actually drives current into MOSFETs to actually do the switching. That stuff, it's just so buried in there. The internals of that stuff that like a National or an LT's making, you're never going to be able to touch that stuff. And if it's doing it wrong, how do you ever even really tell that it's that chip doing it wrong? So that's
that's the thing. That's the art of electronics, isn't it? I mean, you really have to understand your basic building blocks for starters. If you're just a microcontroller guy and your DC to DC converter's playing up, well, you're just screwed, aren't you? You can start plugging parts in and out until it works. That's the old Japanese method of
shotgun
engineering, but. But, to actually if your circuit starts oscillating, or starts playing up because you're on some, marginal spec, somewhere, that, who knows, you're getting, coupling because of poor power supply rejection ratio or something, something more obscure like that.
Yeah.
Well, how do you deal with it? Well, it just comes down to experience of, dealing with discrete designs and basic building blocks and all that sort of stuff. So, troubleshooting's an art in itself.
It definitely
really.
Is. There's actually a really good book for that. I didn't list it in this, but there's what's it called? It's like a 9-step process, and I think maybe Jeff Kaiser from Mightyome reviewed it. I saw someone reviewed it at one point, and I really liked it.
Right.
And it's about make sure it's plugged in, obviously. Track your progress. Just really good steps, and like it's a real well written book that shows you how to troubleshoot. I know whenever I talk to like college students or I think it was high school students the last time I asked this, I'm like, do you know what I don't think it was college students. I think it was high school students. Do you know what troubleshooting is? And they're like, not really. And I mean, I was flabbergasted by that, but then I think back to my high school days, and I'm not sure if I would have known what it is either. And it's such a critical skill that it's like until you're actually working on a project and it doesn't work and you're scratching your head, this is supposed to work, you just don't know what it is. So I think you're right about it being an art.
And one thing I've mentioned on my blog before, I think it was one of my live shows, is that, and it's different. You're talking about this 9-step process or something like that. And that can be a good and a bad thing, because troubleshooting is going to differ if you're the person who actually designed it, because you're intimately familiar with it, and then your mind might say, oh, it can't be that. You'll just instantly rule things out. And it turns out, no, that's, the problem really was that simple. You might start looking for the complex things first because you're familiar with the design and things like that. Whereas, I've had, I've been at work and somebody's been working for days trying to troubleshoot a circuit, and they'll finally give up and they'll ask me to come around and have a look, and I don't know the design, I haven't worked on it before. I'll walk up and go, oh, there's your problem. There's your problem.
Yep. Hey, did you think about turning that on?
It was so, it'd be so obvious to someone with a fresh pair of eyes, you know. And maybe if they went through some process,
Well, this is actually more
process,
like
maybe they would have found it. But.
It was like a set of, not a set of rules, but it was like just kind of like tenets of troubleshooting, and that was actually one of them. To get away from the problem for a while. That's such a good piece of advice, because you're not gonna like it if you just keep staring at it.
Yeah, well, the first rule of any troubleshooting is thou shalt check voltages. That is the golden rule of, check your voltages, check your power rails, that kind of stuff first. And there's a whole bunch of rules like that. And I guess you could write a whole book on it. And then you'll find that, well, that's not going to be applicable to your particular niche, problem that you're working on. So, it's... Yeah, one of those things. But you have to have an open mind and actually consider everything. Because I know that I'll have a closed mind if I'm working on my own design, and I'll just go, it can't be that. It's got to be this over here. And you'll spend a day looking at that, and it's like, you idiot, it was never going to be that. But for some reason, your design mind sort of, thought, it must be that over there, and you weren't thinking logically, and so you can get caught up.
Yeah, I actually, while you were talking about that, I was looking for the actual book, and I think I found it. I think it was in, do you know who Jack Gansel is?
Yes.
Yeah, he's
the embedded, yep.
Yeah, and so he was the one who actually reviewed it. It was in his, he has a real good newsletter that I get. And the nine rules, this is Debugging by David Eggins, and I'll try and post the link. Understand the system, make it fail, quit thinking and look at it, which is a really good one, because a lot of times you'll get the analysis paralysis, which is a fun thing to say.
Right.
Divide and conquer, so split up the problem into little tiny pieces and eliminate. Change one thing at a time. That's a huge one. I always end up messing that up.
So do I. Without a doubt, you'll change two things, and then you'll go, oh, it worked, and you go, oh shit, I've got to go back and figure out which one it was.
And then you break it again, and you break something else, right?
I never learn my lesson there. It's one of those. One of those things, you're just hoping to get lucky quicker, and you just don't want to spend the time to methodically do it. And,
that's the hardest part.
Guilty as charged.
Yep.
Yeah.
So the other ones were keep an audit trail, so like keep track of your work. Check the plug. That's my favorite. Get a fresh view, which is what you were talking about, just kind of getting up and looking around, or walking around for a little bit and come back, or having someone else look at it. And then the last one is, if you didn't fix it, it ain't fixed. And I like that one because a lot of times you'd be like, oh, well, I tried it once and it worked that one time. And it's like, no, you got to really try and break it again and make sure it's broken, or it's not broken anymore. Yep. And so, anyways, the book is Debugging.
And you've got to understand why it actually failed. You just can't go, well, that component's dead. Well, why did it die? Is there some transient on your power rail? Is there, did you kill it with static? Did you do, what?
Yeah.
You've got to... But sometimes, you don't have the time to do that. You've just got to fix it and use your best judgment that, parts, fail occasionally. But, it's not really the best option, that's for sure.
That's not the best method. I mean, it's a method, I guess. But
No, but, well, sometimes you're under the pump. If you're at work and you've got to get something done, you will not have time, as much as you hate it, you will not have time to thoroughly investigate the problem. And you've just got to, make your best judgment. Is this going to be a problem in the future? And well, it's that comes down to big companies and how they operate and things like that.
Let's not get Steve started on that.
Yeah, well, we could do a whole hour on that one.
Oh, boy.
I'm sure we should do that sometime. Dilbert Land.
Oh boy, let's not start that.
Yes.
Yeah, I mean,
I think we've got
go ahead.
time for a couple of. I think we've got time for one more thing. Is there anything we have? Left to cover?
Well, there's one thing I want to mention. Do you ever go to DIY drones before?
I've seen them once. Yeah.
Yeah.
Yep.
So
they sell kits for little drones and planes and things, don't they?
Yeah. And so I just saw this today. I mean, some of those lists I made about last week, so I felt bad about it having a little bit older. But one thing that I saw today is I was on Chris Anderson's Twitter feed. He's the guy that wrote The Long Tail and Free, and I think he's one of the editors at Wired, and this guy does everything. But he helped start DIY drones, I think. But a guy named I hope I don't say it wrong, either Johnny or Yanni, maybe Jani, and he basically has a kit, like a full kit for a quadcopter. So you can go out and just buy a quadcopter based on the Arduino, and it's all going to be open source. Like the parts are all there. It's going to be like somewhere from $300 to $400, so not cheap.
Yeah.
But like you think about like the work required to just get one up and running, and this guy's done a ton of work.
Oh yeah, it's phenomenal. It's a huge amount of work, especially in the software side of things, and just the control algorithms to keep it stable and all that sort of stuff. There's a huge amount of IP that goes into something like that, and to give that away is just great.
Yeah.
This company, the drone company, they're one of the ones who are, I think everything of theirs is open source hardware, is it? They're one of the.
So yeah, they're pretty good. Yeah,
they're one of these new they're now it's a multi-million-dollar company, just like Adafruit have cracked the $1 million mark or something like that, and all these other companies, and that are making this open source hardware, and they're making, millions of dollars business out of all this open hardware stuff. It's fantastic.
Yeah, it's brilliant. I mean, it's when people, like you said, doing all that work and then just giving it back. It's and you kind of wonder about like, oh, well, isn't someone just going to cut me out and just do all the manufacturing? It's like, well, maybe you want that. I mean, like when you said you were going to do your project open source, probably. And
well, there are various levels to making it open source. With the license, the Creative Commons license, you can open it free where anyone can go manufacture it, or you can give away all the information, but then you retain the rights to actually manufacture it commercially, which is also a good option. But I think that's frowned upon in the open source community. But I don't know why. If you want to, give the information for free, but hey, you're the only one who can sell it, I've got no problems with that. That's just fine. So there's options out there where you can actually open source your projects, yet, no one's going to come along and manufacture it from under your feet, manufacture it cheaper and take away your market. So,
good.
There's certainly ways to do that. So that's a good thing about all these licenses these days. Back in my day, when I was a boy, there were no such thing as these open source legal licenses. You just have to either write it yourself, or you had to go and pay some lawyer $5,000 or something to do that. But now you can go online, and you've got all these licenses. You can just choose the one that best fits your product, your application, your niche, and just actually publish the information using that license, and it's fully defendable in court if if it goes that far. Fantastic. And that really, those sort of licenses really enable the open. I don't think the open source hardware industry would exist if those licenses didn't exist. Really, it wouldn't be as big as it is today.
Right.
So there you go.
Well, good for
them.
And
I think our time's up, Chris.
I think it is.
I think we've done our hour, and it is the amp hour. We don't want to go over, do we?
That's right, and that's the last thing I wanted to mention. One of our more observative members... observative? Did I just say that?
Yes, you did.
Anyways, well, Roger, he came up with an alternate name for the show, the 3600 coulombs.
3,600 cool ohms. Neat.
Just brilliant.
Maybe it's available as a .com. Maybe we should register.
Oh, maybe. If not, that can be our competition. Someone else can register
right.
there.
It could be. Anyway,
yeah.
It's been a good show again, and thanks everyone for joining us. If you've listened to the hour, I hope you found it interesting and you've subscribed to the RSS feed, because that's the best way to do it. If you don't understand how RSS feeds work and things like that, then really go check them out, because, I've got people turn up to my site every day waiting for me to release a new video. It's like, well, you don't have to do that if you don't want to. You can sign up to the RSS. Nice, just stop by.
Yeah.
Sign up to the RSS feed and it'll automatically be, or iTunes, it'll automatically be downloaded to your phone or reader or Google homepage or something like that. So
yeah, it's really nice. Yeah. All right. Well.
All right. Thanks, Chris.
Yeah, we'll talk to you next time,
And
Dave.
thanks, everyone. Yep. See ya.
Bye-bye.